Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 5 of the condensed matter physics. Okay, so in which we are going to discuss the crystal structure. It is part 5 and Miller indices. Okay, and also atomic density of different types of planes. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, well, so I'm starting. Let's get started. Okay, so now I will explain 3D crystal. I'll explain 3D crystal structure. Okay, and the brevis lattice and the condition, which are very important. I'll make a table for it and you need to note down. Okay, and I'll tell you trick as well so that you can easily uh, remember it. Okay, so 3D crystal, 3D 3D crystal, 3D crystal, 3D crystal structure, 3D crystal structure. Okay, 3D crystal structure. So I'm going to make a table for it. Okay, so here crystal. Okay, and then brevis lattice, very important table. Okay, for exam purpose, brevis brevis lattice, brevis lattice and condition. Okay, so crystal. So first we will talk about cubic crystal. Okay, so we have a 3D cubic crystal. Okay, cubic crystal and brevis lattice are what are the brevis lattice for cubic crystal, that are SC, simple cubic. Okay, and base centered, and FCC the brevis lattice for cubic crystal. Okay, these are brevis lattice for cubic crystal, and this is body centered. Okay, body centered. So body centered. Okay, and what are the condition is in cubic crystal, that is A, all sides are equal, right? A equal to B equal to C, and angle is alpha equal to beta equal to gamma equal to 90 degree. Angle is 90 degree, right? This is the first 3D crystal, that is cubic crystal. Okay. Second is tetragonal structure, tetragonal crystal. Okay, tetragonal. Okay, the second is tetragonal. Okay, tetragonal, and is the brevis lattice for it. This is brevis lattice for it is, that is primitive. Okay, okay. So my apology, guys. So this one, this is brevis lattice for cubic are FCC, BCC, SC. Okay, simple cubic, that is SC, BCC is body centered cubic crystal, and face centered cubic crystal. For tetragonal, the brevis lattice are primitive, primitive, and body centered. Okay, primitive and body centered. These are the brevis lattice for trigonal crystal. Okay, body centered. Okay, body centered. And for tetragonal, A and B, tetragonal A and B are equal, but AB are equal, but they are not equal to C. Okay, and for tetragonal, this alpha angle alpha equal to beta equal to gamma equal to 90 degree. Angle is 90 degree. Okay, that is alpha equal to beta equal to gamma equal to 90 degree. Okay, now third is, so there are seven crystal. Okay, seven crystal, and they have Brevis lattice corresponding to those crystals. Okay, so third is orthorhombic, 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 orthorhombic. So what are the Brevis lattice for orthorhombic crystal? That is primitive, body centered, and face centered. Okay, so this is primitive, body centered, body centered, face centered, face centered, base or oblique end centered. Okay, base oblique end centered, base oblique and centered. So these are the primitive. These are the Brevis lattice. Okay, and for this the condition is so for orthorhombic A equal to for orthorhombic this is for orthorhombic, right? So orthorhombic, you can see A not equal to B, not equal to C. A, B, and C will not be equal. Okay, and for orthorhombic, but angle is alpha equal to beta equal to gamma equal to 90 degree. Okay, so alpha, beta, gamma angles are 90 degree, but sides A, B, and C all are not equal. Okay, so this is for orthorhombic crystal. Next is rhombohedral or trigonal. Okay, right in next page. This is crystal. This is Brevis lattice. This is Brevis lattice, and this is condition. This is condition. Okay, okay. Guys, just give me 1 second. Okay. Okay, guys. Thank you. So now I'm going to proceed further. So this is crystal, that is Brevis lattice and condition. Okay. So so now this is trigonal. Okay, trigonal or orthorhombic. Okay, sorry, my apologies. It's rhombohedral. Okay, rhombohedral, or we can say trigonal, trigonal, trigonal. Okay, rhombohedric or trigonal. So what are the Brevis lattice for this? For this, Brevis lattice is primitive. Primitive, very important chart, guys. Okay, very important table. And it's a rhombohedral or trigonal. Okay, rhombohedral or trigonal. Okay, for this the condition is all sides are equal. A equal to B equal to C. A, B, C are equal. Okay, and for angle alpha equal to beta, but that is not equal to alpha equal to beta, and that not equal to, sorry, this means alpha and beta, those are not, alpha, beta, and gamma not equal to 90 degree. Okay, so alpha equal to beta equal to gamma, but they are not equal to 90 degree. Okay, so this is for trigonal or that is, this is the trigonal or rhombohedral crystal. Okay, the Brevis lattice for it primitive, and this is the condition for it. Okay, so this is There are 7 crystal, okay, and the fifth is hexagonal, okay, hexagonal. I'll tell you trick as well. Hexagonal, hexagonal, okay. So for hexagonal, the brevis lattice is primitive, okay, primitive. Brevis lattice is primitive. Brevis lattice is primitive, okay, and the condition is A equal to B but not equal to C. A, B are equal, but the third side is not equal, okay. And angles for hexagonal are alpha equal to beta equal to 90 degree, and the gamma value is 120 degree, okay, 120 degree. Okay, now the fourth crystal is, my apologies, sixth crystal is monoclinic, okay, monoclinic. These crystals are very important. So you will get, you, you must know you should know these condition, guys, because you will get questions where this condition is required to solve that question, okay. So monoclinic, monoclinic. And what are the brevis lattice for monoclinic? That is primitive, that is primitive and base centered, okay, primitive and base centered, okay. And what are the condition? The condition is for monoclinic, alpha A not equal to B not equal to C, okay. So ABC are not equal. And angle, about angle, this is alpha equal to beta equal to gamma equal to 90 degree, okay. Alpha, beta, gamma, this is 90. Now last crystal is seventh crystal, that is triclinic. It is monoclinic, it is triclinic, okay. Triclinic, triclinic crystal. So what are the brevis lattice? The brevis lattice is primitive only, primitive, okay. For triclinic, the brevis lattice is primitive, okay. And here primitive also I have explained in my previous lecture. So this is here in monoclinic, this is A not equal to B not equal to C, okay. Yeah, A not equal to B not equal to C, okay. And what are those, that angle condition? For angle also in triclinic, alpha not equal to beta not equal to gamma. So alpha beta not equal to gamma and not equal to 90 degree, okay. Alpha beta gamma are not equal and they are not equal to 90 degree. So this is the very important table, guys. You must know this table, okay. And I will solve question, and I'll show you how we are going to use, how this chart is going to be used, okay. Meanwhile, just let me check whether I'm audible or not. Okay, thank you, transfer, thank you so much for that. My pleasure, transfer. Okay, so let me just check I'm audible or not, okay, then I'll proceed further. Structure, yes, I'm audible, so I'm going to proceed further. Okay, well, so this is the these are the crystal. There are 7 crystal, okay, and these are brevis lattices, and this is the condition. Now I'm telling you the trick how you are going to learn these crystals, okay, which is important, okay. Well, okay, so I'll tell you. So there is a trick for this, okay. Trick is TC, that is take care, Tom TH, okay, take care Tom TH, Tom TH, take care Tom TH. I have written this. There is a reason, okay. I'll tell you what is the reason. T stands for this T stands for trigonal, okay, trigonal. T stands for trigonal and C stands for cubic, okay. Tom Tom means, and T, this stands for this one, triclinic. O, orthorhombic. M, that is monoclinic. And T, it is tetragonal, and this hexagonal. Okay, I'll write this. Okay, T is this is this trigonal, right? Trigonal. Trigonal. T means take care Tom TH, or you can say TC Tom TH. Okay, this is very simple. You can learn it. It's cubic. This is cubic. Okay, now this is Tom. This is triclinic. 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 Triclinic, and this is orthorhombic. 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 Okay, and M stands for monoclinic. Monoclinic. Okay, T is tetragonal. This is what you need to learn. Okay, tetragonal, and this is uh, hexagonal. I have written in this manner. There is a reason, right? Means TC, that is trigonal cubic. There is this TC Tom TH. Why? Because in this TC means trigonal and cubic. All sides are equal. A equal to B equal to C. Okay, for these two, all sides are equal. For this term, that is a triclinic, orthogonal, and monoclinic. For that, A not equal to B not equal to C. So for these three crystal, the sides are not equal. For these two crystal, that is trigonal and cubic, all sides are equal. Okay, and for hexagonal and tetragonal, two sides are equal. A equal to B but not equal to C. Okay, so this and this is important chart, guys, and this is a trick you need to note down, guys. Very important. Take care Tom TH, or you can say TC Tom TH. Okay, so T for you need to understand first. T for trigonal, guys. Trigonal cubic means these two crystal have this have these two, in these two crystal all sides are equal. Okay, and Tom means triclinic, orthorhombic, and monoclinic. In these three crystal all sides are not equal. A not equal to B not equal to C, because we will be asked in question. We need these sides. Okay, for getting the intercepts and Miller indices. I'll solve one question, then it will uh, it will it will clear your doubt. Okay, and then in TH, this is tetragonal and hexagonal. For tetragonal and hexagonal crystal, both two sides are equal, but third side is not equal. So A not equal to B. Okay, so that's why. So I would suggest you, this is a trick, very easy. Take care Tom TH or TC Tom TH. Just you need to know there are three T, guys. So you need to know this T means trigonal, this T means triclinic, and this T means tetragonal. Okay, so practices you will easily learn. Okay, well, okay, okay. So now this is the trick, guys. Okay, so now next is this is the trick. Okay, so next I'm going to solve one question and I'll tell you how it is going to be used. Okay, so question one is find find the Miller indices. I have already told the formula how to find Miller indices in my previous lecture, so please you can check it. Okay, find the Miller indices. Find the Miller indices. Find the Miller indices. Find the Miller indices. Find the Miller indices of a plane. Miller indices of a plane. Miller indices of a plane that intercepts that intercepts that intercepts on ABC axis, on ABC axis, AB, okay, that that intercepts on AB and C axis, AB and C axis equal to 3 angstrom, 4 angstrom and 3 angstrom. Okay, well, in a tetragonal, okay, tetragonal crystal, with C by A equal to 1.5. Okay, so this is a question and options are given. Very good question. Okay, so this is 236, 236, 236. Option B is 436, 436. Option C is 136, 136, and option D is 336. Okay, so these are the options. Okay, so this is the question, guys. Okay, find the Miller indices of a plane that intercepts on ABC axis equal to 3 angstrom, 4 angstrom, 3 angstrom, 4 angstrom, and 3 angstrom in tetragonal crystal with C upon A equal to this trick which I have told you. It is going to work here, right? The trick is take care Tom TH. Okay, so you need to understand there are 3 T, and the first T is trigonal crystal, second T is triclinic, and third one is tetragonal. Okay, tetragonal. So for TC means trigonal and cubic, all sides are equal. A equal to B equal to C. Okay, that's why I have written in this fashion. And Tom means this one. For Tom means trigonal, triclinic, orthorhombic, and monoclinic. All sides are not equal. Okay. And for this TH, that is tetragonal and hexagonal, two sides are equal, third is not equal. This is what we are going to use here, right? So in this question, see the crystal is given tetragonal. Tetragonal is given means we need to know this condition. Okay. If you know this trick, then we can easily know. Okay. Take care Tom TH. Okay. So this is tetragonal, and in tetragonal, both two sides are equal, third is not equal. Now we will use this in this question. Okay, and if so, if we don't know this condition, then we would not be able to solve this question, guys. So that's why this trick is important, and you need to learn it. Okay, well, so I'm going to solve now. Okay, so I have already explained in my previous lecture, that is HKL, that the formula for Miller indices, HKL equal to this A upon OA, these are intercepts, right? Ratio B upon OB, ratio C upon OC, right? This is the formula for Miller indices, which I have already explained in my previous lecture, right? Now, now we have to find the Miller indices for this, right? And these are the conditions. So in that, so now we have crystal is given tetragonal, right? Crystal is given tetragonal. Crystal is tetragonal. And in tetragonal, we know the condition, right? This one. A equal to B, not equal to C, right? So this is going to be, in this condition, A equal to B, not equal to C. Okay, this condition we are going to use. So here, HKL is going to be this one. We'll write A. See, in the because it's a this crystal, tetragonal crystal. So A equal to B. So in place of A, and A upon OA, and if we put B, value B is A, right? A equal to B, A upon OB, ratio C upon OC, right? and here the condition is given C upon A equal to 1.5. Okay, so since given C upon A equal to 1.5, this means value of C is 1.5 A, right? In place of C, we'll put this value. Okay, so HKL, this formula is important, right? HKL equal to this. So this is going to be A upon OA. The intercepts are also given. Okay, so these intercepts on ABC axis equal to 3 angstrom, 4 angstrom, and 3 angstrom, right? So OA is given 3 angstrom. Okay, I'll write here as well. OA equal to 3 angstrom, which is given. OB equal to 4 angstrom, and OC equal to 3 angstrom. Okay, these are given. So this is going to be A upon 4, and this is 1.5A, right? 1.5A upon 3. Okay, this one. Okay. Now very simple, so now we can easily solve it. HKL is going to be, A will get cancelled, so this is going to be 1 upon 3 and 1 upon 4, and this is 1 upon 2. Right, but Miller indices should be integer, right? We cannot write Miller indices in fraction. So what we are going to do is we'll take this LCM. Okay, so LCM is 12, so we'll multiply by 12 these three terms. Okay, so this is going to be HKL to make these values integer. Okay, this is 1 upon 3, 1 upon 3 into 12, 1 upon 4 into 12, 1 upon 3 into 12. Okay, so this is going to be HKL is going to be 4, 3 and 12. Okay, so it means the value of HKL are 4, 3 and 12. Okay, so this is the answer, guys. Okay, so we have to find the Miller indices. Okay, in tetragonal crystal. So any type of crystal can be asked, guys. So that's why you must know this trick, guys. Okay, so that you can easily know these sites and you can apply here. If you don't know these conditions, you cannot solve this question. Okay, well, so this is the answer, and which option is matching, guys? Option B is matching, right? 4, 3, 6. No, 4, 3, 6. I think we have made some mistake. Let me check. This is 6, guys. Yeah, 4, 3, 6. 4, 3, 6. So some mistake is there. So this is 4, 3, 4, 3, 4. Should be 4, 3, 4. 4, 3, 4. But how 6? No. 4, 3, 6. That's correct. This is I have made mistake. My apology. So it will cancel the. This is 2, 1 by 2. 1 by 2, right? So this will cancel 6 times, right? So 4, 3, 6. 4, 3, 6. Okay, so which option is matching? Option B is matching, right? 4, 3, 6. I hope you have understood, guys. Next question. Next question is, okay, so next question, question number 2. A plane makes a plane a plane makes a plane makes intercepts a plane makes intercepts of 1 angstrom and 2 angstrom on A and B axis respectively. Okay, and parallel to and parallel to c axis. Okay, find find the Miller find the Miller indices Miller indices find the Miller indices if A B C is given 3 2 1. Okay, a good question. Options are: option A is 3 2 1. Okay, option B is 1 1 1. Option C is 2 2 1, and option D is 301. Okay, so these are the options. Okay, so ABC is given, and it is given a plane intercepts of A and B axis on 1 angstrom and 2 angstrom, means we have been given. Okay, since first of all I'll write the formula is HKL equal to A upon OA ratio B upon OB ratio C upon OC, right? And since we have been given OA is given, that is 1 angstrom, OB is given, that is 2 angstrom, and third is the and parallel to C axis. Okay, this plane is parallel to C axis, means OC is equal to infinite, because they will intercept at infinite, right? OC is infinite. And also we have been given A, B, C. It is 2, my apology, it's 3 2 1. Okay, so 3 2 1. Okay, well, so now we'll put the value. HKL is going to be this one. A, it is going to be A is given, right? ABC is 2 to ABC. A is ratio B ratio C is 2 ratio to 1, right? So it means A, we can write 3 upon OA. OA is given 1 angstrom. 3 upon 1 into B is 2. 2 upon 2, right? 2 upon 2. Okay, 2 upon 2 and 1 upon infinite, right? 1 upon infinity, right? Because intercept on OC is infinity, right? Okay, so this is going to be HKL is going to be 310, right? 310. So it means value of HKL Miller indices is going to be 310. Okay, so this is the answer, guys. Okay, this is the answer. Well, okay, guys. Next is Miller-Brevis indices. Okay, so what is Miller-Brevis indices? Okay, so Miller-Brevis indices. Miller-Brevis indices. Okay, so Miller-Brevis indices is denoted by HKIL. Okay, HK iota L. Okay, HK iota L. Okay, so here for getting Miller-Brevis indices, H plus K plus I equal to 0. Okay, this is the condition. H plus K plus I equal to 0. So from here, value of H is going to be minus H plus K. Minus H plus K. Okay. So this is the value of I. Now, so this you need to note down. So this is a Brevis, Miller-Brevis lattice. Okay. So if we have been given any plane and whose Miller indices are given, so if we are asked to find the Miller-Brevis indices, we can easily found by this formula. Okay. How? I'm giving you example. Okay. Example is like 110 plane. Okay. So 110 plane is there. Okay. So for 110 plane, you need to find out Miller-Brevis indices. Okay. So here we know. So what we are going to do is we'll find this implies we'll find iota. Okay. Iota is we know this formula. You need to note down. Okay. This you need to note down and then you can put value here. Okay. So iota is minus H plus K, right? And H is these are HKL, right? So iota is going to be minus iota is going to be minus 1 plus 1, right? So this is going to be minus 2. So iota is minus 2, but we cannot we write minus 2 as a 2 bar, right? In Miller indices, right? Because we don't write negative, we write if negative term is there, we write bar of that, right? So this implies Brevis Miller Brevis indices are going to be H K iota L, right? And this is going to be H, we know 1, K is 1, and this is iota is 2 bar, and L is 0. Okay, so this is the Brevis lattice indices for this plane. Okay, I hope you have understood it, guys. Very simple. Okay, next. Next is this one is interplanar spacing. Okay, interplanar spacing formula I'm going to explain. Okay, very important. Interplanar spacing. Interplanar spacing. Okay, interplanar spacing, and for that we know that is denoted by DHKL, right? Interplanar spacing, this is called DHKL, and this value we know for this is the general formula for this is 1 upon root H square upon A square plus K square upon B square plus L square upon C square. Okay, so this is the interplanar spacing, that is DHKL. Okay, so this is the DHKL value. Okay, so now and for this is the very important formula. And now for cubical structure, cubical for cubical we know A equal to B equal to C, right? So for cubical the interplanar spacing, that is DHKL, is going to be A upon root H square plus K square plus L square. Okay, important one. Okay, these are important results. Okay, because if you put A square equal to B, A equal to B equal to C, so this is going to be A square, this is going to be A square, this is going to be A square, right? So A square will be the LCM, and this A square will go in numerator, and it's a root A square, when value is going to be A, right? So DHKL for cubical structure is A upon H cut square K square upon L square. Very important formula. Okay, these two are very important formula for these are for interplanar spacing. This is the formula for interplanar spacing, that is DHKL, and this is when ABC are not equal, and this is when ABC are equal. Okay, both formula are important. Next, these for okay. So now Now we are going to find that interplanar spacing for hexagonal closed pack structure. Okay, so for hexagonal, hexagonal, for hexagonal closed packed structure. For hexagonal closed packed structure. Okay, for hexagonal closed packed structure, the DHKL value is going to be. This question is asked in CSIR net as well, guys. Okay, so very important. So this DHKL value is going to be 1 upon root 4 by 3. Okay, 4 by 3 root 4 by 3. Okay, h square plus hk plus k square upon a square. Okay, so this is 1 upon root 4 by 3 h square plus hk plus k square upon a square. Okay, plus L square upon C square. Okay, plus root L square upon C square. Okay, so this is very important formula, guys. Okay, this is asked in CSIR net as well. Okay, this is asked in CSIR net, this formula, guys. So it's an important one. Okay, so for hexagonal closed pack structure, the interplanar spacing, that is DHKL, is 1 upon root 4 by 3 h square plus k square plus hk upon a square plus L square by C square. Okay, important one. You must know it. Okay, next we are going to study well. Next is planes in cubical crystal. Okay, so we'll study planes. Okay, I have already explained the different types of plane in my previous lecture. So here we are studying planes and their atomic density. Okay, atomic density and linear density. Okay, so planes in cubical crystal. Okay, planes in planes in planes in cubical crystal. Okay, so we are studying types of planes in cubical crystal. Okay, so first is for SC, that is a simple cubic. Okay, and we are studying that simple cubic. We are studying the plane. We are studying by, this is for simple cubic. Okay, for SC, and we are studying for that 100 plane. Okay, 100 plane, for 100 plane. Okay, 100 plane. Okay, so planes. So we are going to study this plane in cubical crystal. Okay, that is simple cubic crystal. So we know. So what is the 100 plane? This I have already explained. So just make a figure and then I'll proceed further. Okay, so you can check my previous lecture, guys. Okay, so this is, we can take a y-axis. This is, we can take x y-axis at anywhere, right, as per our choice. This is z-axis and this is x-axis. Okay, x-axis. Okay, so here this plane is this 100 plane. I have explained this plane in my previous class, so please check that lecture. Okay, this is the plane. Okay, now we'll find, and these are the atom placed, okay, for simple theory. Okay, for this plane we'll find where n effective is going to be n effective, because this plane is parallel to x and y axis, x and z axis, sorry, z and y axis, and it intercepts at a to x axis. Okay, so for this plane, n effective is going to be this. There are 4 atoms. Okay, 4 into 1/4, 4 corner atom, right? 1/4. So this is going to be 1. N effective is going to be 1, and area of this plane is going to be a square, right? These are a side a, right? So it means atomic density or planar density. Atomic density or planar density. Atomic density or planar density is going to be rho equal to n effective upon area. N effective upon area, right? N effective upon area, and so this is going to be 1 upon a square. Okay, so this is the atomic density for this plane. Okay, and similarly, linear density is going to be for this plane. Linear density is going to be 1 upon a. Okay, now for second is for a simple cubic wave study for 1 plane. Okay, this I have already explained. Okay, 1 plane, and for this again I'll make a figure. Okay, so this is z axis, this is y axis, and this is x axis, right? And for this for 1 plane I have already explained. You can check my previous lecture. This is the plane, guys. Okay, this is the plane. Okay, and these are the corner atoms. Okay, and for this n effective is going to be for this plane, n effective is going to be 1, and area is going to be root 2a square. Okay, so it means the atomic density is going to be 1 upon root 2 a square. Okay, and linear density is going to be 1 upon root 2a. 1 upon root 2a. Okay, well, now this is root 2a, right? Okay, 2a root 2a. Okay, next, third, for 1 plane. That plane is also I have already explained in my previous lecture. You can check it. So this is going to be this is 1. Okay, so this is z axis, this is y axis, this is x axis. Okay, so this is 1 plane. Okay, 1 plane means this one. This plane. Okay, this plane. Okay, this plane is 1 plane. I have explained. Okay, in Miller indices classes. Yes, sir. So for this, n effective is going to be the corner atom, base center is also there. Okay, So n effective is going to be this is 60 upon 360 into 3. Okay, so this is going to be 1 by 2, and area is going to be root 3 by 4 into root 2 a square. Okay, so this is going to be root 3 by 2 a square. So atomic density rho is going to be n effective upon area, right? And this value is going to be 1 upon 2 upon root 3 by 2 a square. Okay, and if you solve it, so this is going to be 1 upon root 3 a square. Okay, and this is, and linear density is going to be 1 upon root 3a. Okay, 1 upon root 3a. Well, so this is the linear density for one plane. Okay, now similarly we'll found the detail for uh, BCC and FCC. Okay, okay, for BCC, for simple cubic. Okay, for BCC, for 100 plane, it is going to be, rho is going to be 1 upon a square. Okay, and linear density is going to be 1 upon a. Okay, second, for this plane, for 110 plane I have already explained, right? 110 plane, these are the plane. Okay, this is 110 plane, this is uh, 100 plane, and this is 111 plane. Okay, so for this plane, rho is going to be, this is important result. Okay, rho is going to be 1 by 4 into 4 plus 1. Okay, this is a case of BCC, so this is going to be 2, and rho, this, my apologies, this is the n effective. Okay, n effective. So value of rho is going to be 2 upon root 2a square. Okay, so 2 upon root 2a square. Okay, area for this is root 2a square. Okay, and similarly for 1 plane, uh, 1 plane, rho is going to be, I'll make a chart, then it will be an I'll tell you the trick, so you can easily remember it. Okay, you can easily memorize. I'll tell you the trick. Okay, so linear density for this is going to be uh, this for density, so this is going to be 1 upon root 3 a square. Okay, and linear, so this is the atomic density, and linear density is going to be, I'm writing LD. Okay, as a linear density, so this is going to be 1 upon root 3a. Okay, now for FCC, for FCC, this is for 1 plane. Okay, for 100 plane, for 100 plane. Okay, uh, rho is going to be 2 upon a square. Okay, and LD is going to be linear density, that is going to be 1 upon, this is 2 upon a square. Okay, 2 upon a square, 1 upon. This is 1 0. Okay, 1 upon a square this. Now for 1 1 0 plane, rho is going to be rho is going to be 2 upon root 3 a square, and linear density is going to be, that is 2 upon root 3a. Okay, now third, for 1 1 1 plane, and effective is 2 for this. Okay, so rho I'm directly writing, then I'll make a chart. Rho is going to be 4 by root 3a square, and linear density is going to be 1 by root 3a. Okay, 1 by root 3a. So now I'm going to make a chart, then it will be, you can easily learn it. Okay, so I'm going to make a chart, and I'll tell you the trick how to learn it. Okay, so this is for linear density. Linear density. Okay, linear density. Linear density. So this is okay. So for this is 1 0 0 plane, this is 1 1 plane, linear density I'm talking about. Okay, it's 1 1 plane. Okay, and this is for, okay, this is for SC crystal, this is for BCC crystal, and this is for FCC crystal. Okay, so chart is important. This chart you need to note down. Okay, this is 1 upon a, this is 1 upon root 2a, this is 1 upon root 3a. Okay, and this is 1 upon a, 1 upon root 2a. Okay, and this is 1 upon a, 1 upon root 2a. Okay, for FCC and the for these planes. Okay, and this is 2 upon, this is 1 upon 3a, root 3a. Okay, and this is 2 upon root 3a, and this is 2 upon root 3a. Okay, so very simple. See, 1 upon a, 1 upon a, 1 upon a. Okay, and 1 upon root 2a, 1 upon root 3a everywhere, right? Only this place you need to change. That's all. This place. This is for 1 1, and for 1 1 0 plane, and for 1 1 1 plane. So this, for FCC it is going to be 2 upon root 2a, and 2 upon root 3a. So you can just write 1 upon a, 1 upon a for this. This is the linear density for SC, BCC, and FCC crystals. Okay, and whose Miller indices are 1 1 0 0, 1 1 0, and triple 1. Okay, now same chart I'm going to make for atomic linear density, atomic density, or planar density. Okay, this chart is very important, guys. Okay, very simple to learn. Write 1 upon a, 1 upon a, 1 upon root 2a, 1 upon root 2a, 1 upon root 3a, 1 upon root 3. Okay, and in this place just multiply by 2. Okay, you'll get this. So it's the trick of learning this linear density. Okay, now atomic density. Atomic oblique planar density. Atomic oblique planar density. Okay, so this is going to be so I'll write this is for 100 plane, this is 110 plane, and this is for 11 plane. Okay, and this is for SC crystal, this is for BCC crystal, and this is for FCC crystal. Okay, so linear density for this is going to be 1 upon, for SC 1 upon A square, for BCC 1 upon A square and 1 upon A square. Okay, similarly 1 upon root 2 A square. Okay, and this is 1 upon root 3 A square, 1 upon root 3 A square, and here 1 upon A square. Here just will change this position. Okay, so this is like this. Okay, so this position, this L position we have to change. Okay, so this is going to be 2 upon root 2 A square and 2 upon root 2 A square. Okay, and this is 4 upon root 3 A square. Okay, so just you need to write simple thing. You just need to write 1 upon A square, 1 upon A square, 1 upon A square, 1 upon root 2 A square, 1 upon root 2 A square, 1 upon root 2 A square, and here you need to write 1 upon root 3 A square, 1 upon root 3 A square, 1 upon root 3 A square. Okay, only this position, this is this position, you can say that this position. Okay, that opposite L, right? In this position, in these two position, you need to multiply by 2, and this here you need to multiply by 4. That's all. Okay, very simple. You can easily learn those atomic density and atomic density. Okay, and linear atomic density. Okay, well, so this is the trick, guys. Trick and table. Okay, next is I'll make a chart directly. Okay, so so we are going to find that interplanar spacing. Okay, for SC, BC, and FCC. Okay, so this is going to be right. So this is like, I'll give one example first for 100 plane. Okay, DHKL is going to be A upon root 1 square plus 0 square plus 0 square. Right. So this is going to be A. For 110 plane, DHKL for SC I'm talking about. Okay, SC, simple cubic. This is going to be A upon root 1 square plus 1 square plus 0 square, right? This is going to be A upon root 2. And similarly for 111 plane. Okay, DHKL is going to be A upon 1 square plus 1 square plus 1 square, right? HKL value are 1. So this is going to be A upon root 3. Okay, right? Since we have below the formula, right? DHKL equal to A upon root h square plus k square plus l square. I have already explained. Okay, right? So now I'll make a chart. This is for simple cubic. Okay, now I'll make a chart for simple cubic and FCC and BCC corresponding to these planes. Okay, so I'll chart. So this is for SC, this is for BCC, this is for FCC. Okay, and this is DHKL, right? D100. Okay, this is D110 and this is D111. Okay, D110. Okay, so just a chart you need to make. This is for this for SC 1 upon this is A, then 1 upon root 2, then A upon root 3. Okay, for BCC it is going to be A by 2, A by root 2 and A by 2 root 3. Okay, and for FCC A by 2, A by 2 root 2 and A by 2 3. Okay, so these are the value. And how to memorize it? This one. This is equal. Okay, so you need to A into A upon root A and A upon root 3. Okay, and similarly this one is same. A upon root 2, A upon root 3. Okay, and then these two are also same, A by 2, A by 2. Just these two you need to note down. A upon root A upon 2 root 2 and this is A upon 2 root 3. Okay, this is how you can find out a DHL, or you can just use this formula and you can find out. Okay, so this is about the Miller indices, crystal structure and atomic density and linear atomic density. Okay, and also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, next lecture is going to be of mathematical physics. Okay, okay guys, thank you. Bye now.